Okay, so let's talk about angles of elevation and depression. Now, for most of you, you would have some former understanding of elevation and depression. So when we're talking about angles of elevation, we're looking up. Think of it as elevating your head to look up. So generally, the elevation angle is some angle going up. If it's an angle of depression, we're going down. So imagine yourself on the top of a cliff, you're looking down, you're sort of depressing your head, you're looking down. So that's how you're imagining it. Now, with an angle of depression, it's not the angle, say we are at the top of a cliff, I'm here at the top of a cliff. That's me. That's Miss Romanen. Top of a cliff. Oh, I'm having so much fun. And then I'm looking down. Now, the way you can think about that horizontal is my line of sight. It's not some, obviously I'm standing at the top of a cliff, there's not some road going out in front of me, but that would be my natural line of sight looking out. This is my eyesight, my big eyes, and I'm looking out. That's my line of sight. So the angle of depression is when I tilt my head where I'm looking. So that's my line of sight when I'm looking down. And the angle of depression is between my normal line of sight and where I look down. I see a lot of people, like if we were to draw, say the black is my cliff edge, in here, it's not there. It's between my natural line of sight and where I'm looking down to. Now, when we are working with angles of elevation and Grace. So when we're looking at particular angles, so say this sort of looks like my cliff situation. Here's me on top of my cliff. I've got my line of sight and I've got where I'm looking down. Now, generally, say I've got a boat out here. Ooh, look at that boat that I'm looking at. And I want to know how far away it is from me, which means that I need to find this side down here. Obviously, this alpha angle up here is not going to do me a lot of good. What I really need is an angle inside the triangle. That angle of depression that I've got is outside my triangle. I can't use it if it's not inside the triangle. So what I'm going to use is one of our geometry principles called alternate angles. Now, I was asked before what these arrows mean. If two lines have these, it means the lines are parallel. So if both lines have these arrows, it means that we've got some parallel lines. Now, our alternate angle theory says if we draw a diagonal line through those two parallel lines, these two angles will be the same. So the angles in here, they're the same. So whatever that angle of depression is, it's going to come here, not next to it in here, in here. Great. Okay, so let's look at our first example. So from point P on the ground. So I've got point P, which is on the ground, and the angle of elevation to the top of the tree. So I've got a tree, and the point of elevation, which means that I'm looking up to the top of the tree. This is my ground down here. And the angle of elevation to the top of the tree is 50 degrees. So this angle in here, how much I'm lifting my head is 50 degrees. If P is 8 meters from the tree, so if this is where I'm standing at point P, and I'm 8 meters from the tree, I recommend that you draw diagrams as you go along as well. 8 meters from the tree, find the height of the tree, correct to 2 decimal places. So I'm looking for the height of the tree. So I'm going to make a triangle out of the situation because obviously we're doing trigonometry. Fantastic. So I've had someone suggest that I'm using tan because this yellow side, the height of the tree, is opposite to my angle. And I've got this side which is adjacent. So yes, I am using tan. So I'm going to have tan of 50 is equal to Just reminding ourselves what our ratio is. Tan theta is opposite over adjacent. My opposite side is what I'm trying to find. So my adjacent 8 meters goes on the bottom, multiplying both sides by 8 to get x by itself. So 8 times tan 50 is equal to x. Pulling out our calculators. And we get x is equal to 9.53. So that means that overall, what does that 9.53 mean to me? Yes, the height of the tree is 9.53 meters. And remember, 2 decimal places. You need to be mindful of decimal places and a unit on the end. Okay, our next example is for angle of depression. So from the top of a vertical cliff, so I'm at the top of a cliff that's 72 meters high. I'm pretty high up. Do you want me to give myself some hair? Will that make you feel better? Okay, so I'm at a 72 meter high cliff, and the angle of depression to the ship, so I'm looking at a ship, is 7 degrees and 11 minutes. So remember, my line of sight, I draw it as a dotted line so I don't get confused with what's actually there versus what I'm imagining is there. So that horizontal line, I draw it as a dotted line. And I'm drawing my actual line of sight down to that boat, and remembering that this angle in here is the angle of depression. So that is my 7 degrees and 11 minutes. Now, I need to work out how far from the base of the cliff is the ship. So this horizontal line down the bottom. So obviously that's the base of the cliff. This is my ship. I want that distance there. So I'm just going to call that x. So first I need to apply my alternate angles. So if I had to look at these 2 lines, this horizontal line and this yellow line are my parallel lines, which means that purple line is the diagonal that runs through them. So when you're looking at which angle to put inside your triangle, it's always the alternate ones, the ones that are opposite each other. So this 7 degrees and 11 minutes is going in here into this little angle here. So that is 7 degrees and 11 minutes. Okay, now that I've got my angle into my triangle, I notice that the 72 meters is my opposite and the x is my adjacent. So building my tan equation again, tan theta, because I've got opposite over adjacent. So tan of 7 degrees and 11 minutes is equal to 72 over x. Great, so after all that, we're getting that x is equal to 571.25. 275. So our question does not specify how many decimal places, so you can pretty much pick. I always like to stick with 2, but you're never going to get marked up or down if it's not mentioned. So the ship is 571.275 meters away from the base of the cliff.